For question 1a, we want to solve this inequality by using this graph. So here we have an equal sign, so we have this solid line, and we have to shade one side or the other. I'm going to use a test point to determine which side of the line to use. And a very easy one to try is 0, 0. I'm going to plug this into the inequality and see if it makes it true. So in place of x, I put 0, and in place of y, I also put 0, and is this greater than or equal to 6 if I simplify it? Well, clearly it is not. 0 is not greater than or equal to 6. This is false. And what this means is, since this point does not work in this inequality, none of these points do. So it has to be that we shade this side of the line. So I'll do that like this. But just to see what it looks like for it to be true, I'm also going to check the point 5, 5. It should be that 5, 5 makes this thing a true statement. I'll put 5 in place of x and y and see what happens. So it's 2 times 5 plus 5 greater than or equal to 6. Well, that's 10 plus 5 is 15. That's greater than or equal to 6. This is true. So, okay, it's definitely this side of the line that I shade. For part B, I have y is less than 0.5x plus 2. So here we have a dotted line, a dashed line. And again, I want to see which side of the line I'm going to shade. And here we have 0, 0 is available to us. So I say we try that. So there's the point 0, 0. I'm going to put that into my inequality and see what happens. So I put 0 in place of y. That's less than 0.5 times 0 plus 2. Is this a true statement? This simplifies to 0 is less than 2, which is true, and therefore I'm going to shade this side of the line. Again, maybe just to see what it would look like if you used a point that didn't work, maybe I'll use the point, how about this one? I'll try the point 0, 5. It should make the inequality false. I put 5 in place of y. This is less than 0.5 times 0 plus 2. Is that true? This simplifies to 5 is less than 2. Okay, this is false. And said another way, I don't want to use the points on this side of my line. All right, for question 2, we want to solve a few equations, starting with this one here. 2x plus 14 equals 3x minus 8. I'm going to start by subtracting 2x to both sides, and this changes my equation to 14 is equal to x minus 8. I will then add 8 to both sides. This is nice that on the right I'm left with just x, and on the left I get 22, making this my final answer. For part B, I have 1 over negative 5 times x is equal to negative 9. I'm actually going to rewrite this. Okay, my goal is to cancel the 1 over negative 5. A very easy way to do this is to multiply both sides by negative 5 over 1. And on the right, if you want, you can make this a fraction, so you're comparing fractions. On the left, the negatives cancel, as do the 5s, and in doing this, we have 1 times x, so I'm simply just going to write x. On the other side of my equation, I have 1 times 1 in the denominator, so I actually don't need a fraction. I have a negative times a negative, which is positive, and 5 times 9 is 45. So here's the answer to the second equation. In part C, this one's a little more complicated because there's parentheses, but all this means for us is I'm going to distribute the 5 as well as the 7 before I combine like terms. So I get 5x minus 20 plus 3x is equal to 7x plus 7. Now the parentheses are gone, I can combine like terms. On the left, we have a total of 8x minus 20 is equal to 7x plus 7. I can no longer combine like terms, so I'm going to start moving things from one side of the equation to the other. I'll subtract 7x from both sides. This gives me x minus 20 is equal to 7. I'll now add 20 to both sides, and I have x is equal to 27, and that's my final answer. For part D, a good approach here is to cancel all of the denominators, or to just remove the fractions from the question. To do this, I'm going to identify the least common denominator. Since we have 3, 2, and 6, the least common denominator is going to be 6. I'm going to multiply 6 to both sides of my equation, and said another way, I'm going to put a 6 over 1 next to each fraction and see what happens. So that is, I get 6 over 1 multiplied to 2/3, and then again I multiply 6 over 1 to x over 2, and then on the right side I multiply 6 over 1 to 1 over 6. This should cancel every single denominator, and it does. 3 goes into 6 twice, 2 goes into 6 3 times, and on the other side of my equation, I'll just replace it with 1s. All of those are 1s. Here's what's left over. I don't have to use the denominators anymore. They're all 1. So I just look to the numerators. I have 2 times 2, which is 4, plus, okay, I have 3 times x, which is simply 3x. And then on the other side of my equation, I have just 1. I can now subtract 4 from both sides. This gives me 3x is equal to -3. And after dividing both sides by 3, I get that x is equal to -1, and that's my final answer. For the next problem, I want to graph the line 2x plus 5y is equal to 10 by using an x and a y-intercept. Let's start by finding the x-intercept. That's where the line is on the x-axis. To do this, we're going to take y and let it equal 0 in the equation 2x plus 5y is equal to 10. So that is, nothing happens to 2x, but in place of y, we put in 0. And this will simplify the equation nicely to just 2x is equal to 10, making it very easy to solve for x by simply dividing both sides by 2. We get that x is equal to 5. And said another way, that's 5 for x and 0 for y. That is my x-intercept, which is right here. If I can also find the y-intercept, where the graph crosses the y-axis, I'll have 2 points, which is enough to graph a line. So let's find that. To find the y-intercept, this time I'm going to let x equal 0 in my equation. So that is, we take 2x plus 5y is equal to 10. In place of x, I'm now going to put 0. And this will make it very easy to solve for y, because I'm left with 5y is equal to 10. And after dividing both sides by 5, I'll write it over here, but I get that y is equal to 2. This is the point 0 for x and 2 for y. This is my y-intercept, which I'll put right here. I just need a basic sketch of this line, so I'll draw the equation, the line that goes between these 2 points. And there it is. I also want the slope for this line. So what is the slope? Well, we have a formula that we could use, but we define this to be rise over run. And since we have 2 points, we can see how far we go down, which is the rise, and then how far we go over, which is the run. Here we drop down 2, and because we're going down, we'll just call this negative. So in terms of my fraction, I get -2, and the amount that you go over is 5, and so that means -2/5 is my slope. In question 4, we're going to simplify these expressions using our properties of exponents. So starting with part A, the way I look at this is I can multiply the numbers together, then the x's, and then the y's. So I see that we have 2 times 4, so I know I'm going to get 8. we can actually group the x's together. There's an x squared, and that's being multiplied to an x, and technically that's the first power. Likewise, there's a y cubed, and that can be multiplied to the y to the fourth. We have a property that says you can add the exponents as long as the bases are the same. So that is, this is 8 times x cubed times y to the 7th. This property simply just tells you how many of these things that you have in a row. And this is the final answer. Now for part B, we need a slightly different rule here. This is different because there's this -2 outside of these parentheses. But the rule that we had is this number is multiplied to both of these values here. So I'm going to simply apply that by saying, okay, I have x, and since there's a 3 and a -2, the product of those two things is -6. Likewise, we have y to the power of -2. If we multiply that to -2, that's going to be +4. One final thing is, I don't want this negative exponent because it's kind of confusing. What it does is it takes the x and moves it to the denominator. And this is my final answer. For part C, all right, for this one here, I'm going to write it just a little bit differently where I have x to the 5th over x cubed, and separately I'm going to think about this as y to the 10th over y to the 9th. In part A, when we multiplied the x's together, we simply added the exponents like this. Here, when you're dividing, you will subtract the exponents. So we have, that's x to the 5th minus 3, and then y to the 10 minus 9. This simplifies to x squared times y to the 1st, and if you'd like, you can just write that x squared y as your final answer. This is a lot of writing for this process. I simply look at this as take the difference, you get 2. Take the difference, you get 1, and that's the final answer. For the last part, let's see what we have here. I'm going to break this again up into, this time, 3 fractions. So it's 12 over -6. Then we get x to the 7th over x to the -2. And then y squared over y to the 10th. When I'm comparing the numbers, 12 over -6, that's just -2. Now here, you can still subtract the exponents even though this is a negative number. I'm just going to be a little bit careful with how I write that. That's 7 minus a -2. For the y's, it's 2 minus 10. I read it this way because I have -2 times x. If you subtract a negative, that's really addition. That's 7 plus 2, which is 9. And here I have y to the -8. Again, I've encountered this negative exponent, so what I'm going to do is take the y and put it into the denominator, making this my final answer. Let's use scientific notation to multiply these two numbers together. What I'm going to do is take what looks like 3 million and 5 billion and write them as follows. So 3 million is 3 times 10 to the power of, there's a total of 6 places to put the decimal point here after the 3, so that is 6. And likewise with 5 times 10 to the power of, let's see, we get 3, 6, 9, so it's to the power of 9. When I multiply these, I'm going to multiply the 3 and the 5 because they're similar, as well as the 10 to the 6 and the 10 to the 9th. Here I can simply just add those two exponents since the bases are the same. So I have 15, and then I have 10 to the 6 plus 9, which is also 15. And the way we wrote this was more of 15 times 10 to the power of 15. But this is not scientific notation because you have to move this decimal one place. You just made 15 smaller. We actually just made it 1.5. And this means your exponent has to get bigger. We're going to increase it by 1. So if this drops down to something smaller, you have to add to make this thing bigger. And this is the final answer. For this last question, it says, suppose that the length of a rectangle is 7 feet longer than its width, and that the perimeter is 86 feet. I'd like to find both the length and the width of this rectangle. So just to draw a picture to see what's going on, here's my rectangle. This is the length and this is the width. It says that the perimeter is 86 feet. This is the total distance around. And if I label my sides as also L and W, P for perimeter is equal to 2L and 2W. The reason for this is it's L plus W plus L plus W again. So here we have a formula about the perimeter, and we're given that the perimeter is 86 feet, so I'm going to put 86 in place of P. If I divide both sides by 2, so I'll just write it like this. If I divide both sides by 2, my equation becomes 43 is equal to L plus W. To solve this problem, we need a second equation. And I'm seeing that it says the length of a rectangle, L, is 7 feet longer than the width. So this is the equation for that statement. The length is 7 feet longer than the width. To complete this problem, I'm going to take L, which is equal to W plus 7, and I'm going to put it right here. I'm taking these two equations and combining them into one. See what happens when we do that. So we have 43 is equal to, okay, I have L, which I know it's actually equal to this, so I'm going to put it here. This is what it looks like to combine my two equations into one. It will allow me to solve for W because I have 43 is equal to, well, there's two W's and then plus 7. I'm going to subtract 7 from both sides. This gives me 36 is equal to 2W. And if I divide both sides by 2, we get that W is equal to 18. That's half the answer. I also need to know, well, what is L equal to? To figure that out, I'll take 18, put it in place of W, and add 7. And this gives me that L is equal to 25.